Our final lesson in this quadratics unit is an actual application of quadratics, which is figuring out exactly how things that are thrown move through the air. They always move with a parabola. I'm sure you've thrown a baseball or a football, and if you've watched the path, it goes up and it goes down and it follows a parabolic path. Maybe the ball goes super duper high, maybe it goes really low. Whatever it does, it's going to do this kind of a shape. So what we can do with quadratics is we can write an equation that describes how high it is at any given moment in time. This is the equation that does that, and a lot of times when kids see this for the first time, it is a little intimidating. We've got all these like weird v sub zeros and h sub zeros. That's how a math teacher or physics teacher would say this. And this upsets people, right? Because who wants to see letters with even tinier numbers next to them, next to other letters? It's obnoxious. But we're not going to let that intimidate us. Because we are smart, young people, and this was written for humans by humans. We just need to figure out what they were thinking and why they did it this way. And here is the general idea. If I'm a tiny little person and I throw a ball but I'm not very strong, so I can't throw it very fast, the ball's going to go like meow and then like meow and not go very high at all. But it'll follow a parabola. If I'm a big, tall, strong person, like this fella, and I chuck this ball super hard, it's obviously going to go a lot higher and land, eventually as well. As time is moving on, the ball goes up, the ball goes down. Regardless if I'm tiny or gigantic, the ball is going to go up and then down. So maybe at 1 second, after 1 second passes, this guy's ball is this high, but this guy's ball is higher because he left his hand higher and he threw it harder. Maybe after 2 seconds, this guy's ball is like here. It's this height from the ground. It's a Y value. This guy, he threw it harder. He left his hand at a higher place. His ball is higher. But the point is, how high that ball goes at any given moment is determined by two things. How hard they threw it. That's what V sub 0 stands for. It stands for starting velocity. That says velocity. Pretend this is velocity. And then h sub 0, which stands for starting height. When we look at this equation, what I would love for you guys to see is not a bunch of v's and h's because that's confusing. I want you to be like, okay, the v stands for how fast it was going when it left the person's hand, and the h sub 0 stands for how high it was when it left the person's hand. We want to put these little zeros on there. They stand for time 0, which means like when the problem first started. And it's important to think about that. I can't just call it velocity, and I can't just call it height, because when this ball leaves this guy's hand, it's going pretty fast. The upward velocity is pretty fast, and as Earth pulls on it, the ball slows down, the ball slows down, the ball slows down. Its upward velocity at some point is 0. It's not going to go up anymore. So it slows down as it goes up, it slows down, and then it starts to speed up, speed up, speed up, speed up, speed up, blah, blah, blah. So the velocity is changing as time changes. The height also changes as time changes. It starts pretty low. It goes higher, 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 higher. The height is changing with every single moment, and then continues to change. So what is affecting the ball's motion in the first place? The starting velocity and the starting height. The velocity at time 0 and the height at time 0. That's what these two things stand for. So as far as filling in these blanks go, this h sub t means h as a function of time, height as a function of time. This is just if I give you a specific time, it'll tell me the height at that time. So if we'll get into what that means more as we go on, but this is something that always changes and always depends on what time we're talking about. So if you get a specific time, you can use this to find the specific height. The t in this equation, this t, this t, this t, all these t's, they all stand for the same thing. They stand for how much time has passed. V sub 0 I just talked about, but it stands for starting upward velocity. Now, I throw that word upward velocity in there, and if you're not in physics, you may not know what I mean by this, but when you throw a ball, there's two velocities going on. There's a velocity that pushes the ball up, and there's a velocity that pushes the ball over. And it's the upward velocity that determines how high the ball goes. So you don't need to worry too much about this. Anytime I give you v sub 0, it'll be an upward velocity. I'm just throwing that out there. You'll see that upward in there. Don't worry about it. We need it to make the problem official, but it doesn't affect what you do with it. And this last portion is the starting height. So what we're going to do in the next few examples is we're going to get some information about a situation where something's flying through the air. We'll probably get the starting height and the starting velocity, and from there, we'll be able to write an equation that looks like the equations we've been working with. So then I might ask you to find the vertex, or I might ask you to graph it, or I might ask you to find, what happens when t equals 3 seconds, stuff like that. We're going to get an equation. It's going to be great. Don't let these little zeros fool you. They just mean starting velocity, starting height. Let's do this. Yeah.